Hello, yeah, good morning. Is it clear for you? Is it audible? Okay, fine, yeah. All right, fine. Right, let me go with this. So last session we were discussed this subversion concept, right? SVN. Okay. So we have seen some limitations for SVN for subversion. I said right, subversion is one centralized repository, so which can have this in single repository. So multiple developers will add their code for this repository. Okay. Multiple developers will add their code for repository. But go for this distributed version control system like Git. Here, every developer will have his own local repository. So they will add their code for first to its local repository. So then they will commit their code for central repository. Okay. See this advantage. In case of subversion, like SVN, if you lost this network, then developers cannot commit their code. They cannot add their code. And go for distributed. Even you lost this network, developer can add their code for local repository. Okay. So in the case of distributed version control system, here every developer will have his own local repository. Okay. Fine. Now you can see like how this distributed version control system like Git will work. You can just see here. Okay. See this one, Git. So after we discuss this, the centralized and distributed version of the systems, okay, and go for this. It is an open source distributed version control system designed to handle everything from small to very large projects with the speed and efficiency. Okay. So what is Git here? It's an open source distributed version control system designed to handle everything from small to very large projects. The speed and efficiency. So compare with this SVN, Git performance is high. How can I say this? Here we have our own local repository. So we can commit this code for local repository. Okay. So compare with the subversion, this Git performance is high. And Git is a distributed version control and source code management system. Git is what? Distributed version control and source code management system with an emphasis on speed. Okay. Next one. Git was initially designed and developed by Linus Torvald. You know, he's a guy who developed Linux operating system, right? So he's a guy who was developing this Git tool here, and it was designed for Linux kernel development. And Git is a free software distributor under the terms of GNU. Okay, and it is commonly used for source code management (SCM). Okay, so already we discussed this. We can call these tools like a SCM, like source code management systems, or I can say it is VCS. What is VCS? So version control systems, or else RCS. So revision control systems, right? So you can call it as some source code management systems, or version control, or revision control systems, right? So it said it is commonly used for source code management. Okay. And if you go for SVN, we have some limited layers. Okay. You see the layers of SVN. We discussed this. Excuse me. Right. Here we have some central repository, and there is some working copy. So every user will have his own working copy. So first they will get the code from the central repository, then they will modify the code. That code they can commit to this repository. Okay. So it is in case of SVN. So we have some two layers here. But go for Git. In Git we have multiple layers. Okay. We can see this Git process. Here we have some local repository. Okay. This is in user environment. In user environment. So we have a local repository, and we have some index area. This index area is also called as cache area, or stage area, and we have working directory or working copy. Okay. Now you can just see this, and the remote repository. Here, remote repository is either like GitHub, or it could be GitLab. Okay. Fine. See this process here. So first the developer will get the code from central repository. Okay. And we can call the process as a, in SVN, if you get this code from central repository, then how we'll call it? As checkout, right? Okay. In SVN, if you got the code from central repository, you will call it checkout, right? But go for Git, if you got this code from central repository, then you will call it as a clone. Okay. So what is clone here? A clone is a process of retrieving a copy of repository. Okay, you can use a command like git clone to get the code. Okay, and you can also use a command like fetch. So fetch command can get the code up to local repository. Okay, and you can go for pull. Tell me, in SVN, how will you get the other changes, other developer changes? In SVN, remember we said update, right? But if you go for Git, in Git we are using pull command. Git pull command. Okay. And next one, checkout. Checkout is a command to revert changes. So if you want to do some changes, if you want to roll back the changes, you can go for checkout command. Actually, checkout can use in different cases in Git. Okay, I'll tell you later, like how to use this checkout. Okay, and what this head you will see it. Okay, and next one. So once we got the code, once we clone the code we can modify. Okay, we can just modify this code. So that modified code we can add to our stage area. Okay, so here the modified code we can add to stage area or index area. Okay, then the code will commit to local repository. We know in SVN commit means what? We can add the code to central repository, right? But in Git, if we do commit, the code will add it to local repository, not for central repository. Then how to add code for central repository? The command push. If you do git push command, then this code will move to central repository. Here central repository could be GitHub. Okay, we can add our code for GitHub. Okay, and we can also use GitLab. Okay, even GitLab can maintain our code. Okay, It will act like a central repository. Okay. So, and I will call this process as a three tree architecture. Three tree architecture. Okay. So see this process here. So what are different layers in Git? I said one is like remote repository. Okay. So there we can have some central data. Next one here we have some local repository. Okay. And index area is also called as cache or stage area, and working directory. Okay. So for all these three layers are present in our user environment, and it is a remote repository. Okay. And what is the first step here? We can get the code, the clone command, or else can use fudge. That code we can modify. That modified code can add it to stage area. Then we can add the code to our local repository, and then we can push the code to central repository. Is clear? So we have multiple layers in Git. Okay, and I'll call this structure as a three tree. Is not tree type. Three tree architecture. Okay, fine. Now if we go for other layers of Git. Actually, this slide will compare both SVN and Git. Okay, we know we have some SVN repository, right? Subversion. Okay, and we'll compare with this Git. Okay, so let us see how these two things will work. If it is SVN, how we'll get the code? See this process here. In Git, we can use a command like fetch or clone. Okay, fetch or clone commands are used to get the code from repository, from the central repository. Okay, and if it is SVN, how to get the code? The command word checkout. Okay, see this one. We can use fetch or clone commands, so it creates a copy of remote repository at our local system. Okay, and compared to CS, what is the CSV? Centralized version control system. Centralized version control system. What is centralized one? SVN. Okay, so compared to SVN, what is it? In SVN, how will you get the code? Checkout, right? Yes. So in SVN, you will get the code with the command like checkout. Okay. And next one, once you got the code, that code we have to modify. So modify the files at local branch. Okay. So once we got the code, so that code we have to modify. Okay. We can modify the code. That modified code we can add to index area or stage area. See this one. So once the files are modified, then you can do stage the files. But see this statement here, no CVS comparison. No CVS comparison. That is, in centralized version control system, we don't have any stage area, right? So the statement is no CVS comparison. Next one, commit the files locally. Commit files locally. Like in sense, we can save the files in a local repository. And one more statement here, no CVS comparison, right? In case of centralized version control system, like SVN, do you have any local repository? No, right? That is, there is no index area and stage area, sorry, index area and local repository in our central repository. But in case of Git, yes, we have these two layers, additional layers, right? So is what commit files to locally. And finally, what we can do? Push changes to remote repository. I said in SVN, how will add your code to central repository? The command word commit. Okay. So in SVN, you will use commit command to add the code for central repository. Go for Git. In Git, how will add the code? Command like push. So push changes to remote repository. It's clear for you. So see the steps here. First thing, you have to fetch the code, or you have to clone the code, and you have to modify the code. The modified code we can stage it, okay, add to stage area, and then we can commit these changes to local repository, and finally push changes to central repository. It's clear for you. This is what Git workflow. Okay, so in this slide we'll just compare both Subversion and Git. Okay, fine. So we have another diagram here, so which represents this complete data flow of Git. Okay, so let us see how this Git will work. See this one. Here we have our workspace, working area, stage area, and local repository, remote repository. Okay, what is first up here? We have to get the code from remote repository. Okay, so we can use a command like clone. We can clone the central repository, get the code, and you can also use a command like pull or rebase. Rebase will have some different functionality. I will discuss later. Okay, how this rebase will work, I will discuss later. So we can get the code from this remote repository. Fine. Then that code we can modify. We can modify the code. That modified code we can add to stage area, right? Then the code we can commit to our local repository. Okay, you can use the commands like add and next one commit. Okay, then this code will move to local repository. Or else you can use one command like commit hyphen a. What commit hyphen a will do here? It will first add our code for local repository, not stage area. From there, it will commit the code to local repository. Okay, so we can add and commit at once with this command like commit hyphen a. Okay, and next one we have another one like push. So what are the code we have for local repository? That code we can push to remote repository with this command. Okay, and we discuss how to get the code to local repository. How to get it? The command like fetch. Okay, so fetch is a command to get the changes from remote repository. Okay, fine. Next one, to revert changes. If you want to cancel changes, okay, we can use the commands like checkout command. Okay, and if you want to get the code from stage area, okay, already we have some code in stage area, so I want to unstage the code. I want to get my code back. Okay, so then I will use reset command. Okay, so reset is a command to get the code from stage area. Okay, and we can call it as unstaging the code. Okay, the question is what is this head? You can see even head here. Okay, so if you want to do this code comparison, okay, you can use a command like a diff command. So with this diff, you can just compare our code. Okay, fine. Now the question is, what is this head? Yep. So head is one most recent commit ID. It's what most recent commit ID. So do you remember in Subversion, if we have any changes, we got some revision numbers, right? Yes, we have some R1, R2. Okay, what are the revision numbers? Okay, so for any change, you'll get some new revision number. Okay, so in case of SVN, but go for Git is not like this. Git will have some commit IDs. What Git contains here? Commit IDs. A commit ID is a combination of all form numeric values. I said one commit ID, some A, B, C, D, 1, 2, 3, something. This is a commit ID. Some X, Y, Z. Okay, this is a commit ID. So like this, a commit ID is a combination of some alpha numeric values. If you do some bank transactions, okay, if you do some withdraw, deposit, what you'll get it? You'll get some transaction ID, right? The same way, if you do some changes in your Git repository, you'll get some commit IDs. Commit IDs. Okay. So if you do some initial commit, then head refers the first commit ID. So is a head it is. Okay. And if you do one more commit, then head refers to the next ID. If you do a new commit here, now head refers this point. That is, head position will always changes. Okay. So head doesn't have any fixed position. Okay. So if you do a new commit, then always head moves to its next commits. Okay. So we can have some commit IDs. Okay. So our head refers what? The most recent commit ID. Okay. It's clear for you? So what are different layers here? One is asset, workspace. Okay. And next one what? Stage area, local repository, and remote repository. So how to get the code from remote repository? Yes, what is the command I said? Clone, yes. So clone is a process of getting the code from central repository. You can use clone, you can also use pull command. I said if you want to get other developer changes, if you want to get someone changes, you can use a command like pull. I said rebase I'll discuss later. Okay, some different functionalities. Okay. And once we got the code, that code we have to modify. Okay, we have to modify it, workspace. The code we can add to stage area. Then we can commit to local repository. Or else we can do this process directly. The command like commit -a. Okay. And the modified code is there in local repository. Then how to move this code to remote repository? I said push. Okay. And you can use fetch command to get the code up to local repository. And how to revert changes? The command like checkout, or else reset. This question will ask in interviews generally, what is git reset? Okay, or they'll ask a question like this: how can you unstage the code? How can you get the code from stage area? Okay, so a command like reset. Okay, and one more thing I said, code comparison. You can do this comparison with a command like diff. Okay, if you want to compare the code between two commit IDs, okay, you can use diff command. And I said head denotes what? Most recent commit ID. And if you do any change, you'll get some new commit ID. And commit ID is a combination of alpha numeric values. Is it right? The question is, each commit ID contains how many characters? Yep. Each commit ID contains nearly 40 characters. 40 characters are there. Okay. But if you want to handle the commit ID, you have to use at least 7 characters. At least 7 characters are required. But actually, each commit ID will have nearly 40 characters. Okay. It's clear? Fine. So there are some different layers in Git repository. Okay. Fine. Next one, here we have Git terminology. Okay. So we have seen some SVN terminology, subversion terminology. Okay, it is a Git terminology. One is like repository. We know repository will do what? Git repository as a directory that stores all files, folders, content needed for your project. So a repository will always store some files and folders and the content needed for our project. Okay. And if we go for branch, just like SVN, in SVN we have branches, right? In Subversion, so here also have branches. See this one, a version of the repository that diverges from main working project. Okay. So already we discussed this. If you go for this SVN, so what is the main working copy? I said trunk, right? Trunk. But go for Git, he will call it as a master. Okay, here the main branch is what? Master. And we can have some another line of development. Okay, I'll call it as branch. So branches are what? Another line of development or parallel development. Okay, these are what? Branches. And we can have some tags. Here we can have some revision numbers. So revision 1, revision 2, we can have some revisions, right? Earlier case we have some revision numbers like R1, R2, all these things. So right now we have what? Commit IDs. Okay, what we have? Commit IDs. Okay, I said one commit ID like some A, B, C, D, something. Okay, so commit ID, one more commit ID, something. We can have some alphanumeric values, but we know this. We may not identify these commit IDs always, so we can use some tags. Okay, let me provide some tags here. Here I said tag some form tag I created, and next one some table tag. So for different commit IDs, I'll use some different tags here. Okay, so I'll call it as all tags. Okay, so for all these commit IDs, we have different tags. Okay, fine. So see this things here in SVN in subversion. What we have? Trunk, tags, branches, and go for Git. Here what we have? Master, tags, branches. It's clear for you. So tell me, what is trunk? A trunk is a main development area. So there we can have some code. Okay, and go for master. I said Git can have a master branch. Okay, which can have some code, the main development. Next word, tags. Tags are what? Some named snapshots. We provide some snapshot for this commit IDs. So I'll call it as some tags here. Next one, branches. Okay. So what are branches? We said another line of development or parallel development. It's clear for you. So the terminology we have in SVN and in Git. It's clear. So branch is what? It's a version of the repository that diverges from the main working project. Okay. And branches can be a new version of repository. Fine. Next one, clone. We discussed this. What is clone? This clone command, we can get the code from central repository. If you want to get a copy of repository, use clone. See here. Clone is a copy of repository or the action of copying the repository. It's what clone. Okay. Next one, master. Yes. In case of SVN, trunk is a main branch, right? But go for Git. So Git contains master. So master is a main branch, primary branch. Okay. So master is the primary branch for all repository, and all committed and accepted changes should be on the master branch. Master branch. Okay. And you can work directly from master branch or create other branches. Yes. You can directly work on master. Okay. You can just log into master, you can work. Or else you can create other branches. It's clear for you. Next one, checkout. I said right, in SVN, checkout means what? In subversion. So in subversion, checkout means to get the code from remote repository, right? But whereas Git, in Git, checkout can use in different cases. Can use in different cases. So I'll show one image. You get some idea. Just see this one. So are you able to see this one? Right. So here you can observe. Here we have some master. You know, master is the main branch, primary branch, and we have other branches. And there are some different commit IDs. If you do any change, you got some new commit ID here. Okay. And commit IDs are like this. Fine. And what are the code we developed on branch? That code we can merge to master. Okay. So here, what is merge here? It is a process of adding the code from central repository to our master. Okay. We can merge the code from branch to master or master to branch. Okay. So both are allowed. Okay. And next one, checkout. Actually, checkout can use a different case here. If you want to switch from one branch to another branch, you can use what command like checkout. Okay. So with this checkout command, we can switch. We can switch between two branches. Okay. What checkout? Next one, head. We discussed this. What head denotes? Most recent commit ID. Okay. So like this, we can have some Git terminology here. So what is checkout? I just said to you, right? Checkout can use in different cases. One case we discuss. If you want to revert changes, we are using checkout, right? And it is a different case here. If you want to switch between two branches, if you want to move from one branch to other branch, we are using again checkout command, right? See this one? The git checkout command is used to switch branches in repository. Okay, so if you want to move from one branch to other branch, you can use a command like checkout, right? So next one, merge. What is merge here? Yes, taking the changes from one branch and adding them to another branch. Okay, so where we can add? Generally, you can add for master branch. So traditionally, it is master. We can add even for other branches. Okay, so is what Git terminology. Like master is the primary branch. Okay, and checkout is a command to switch. Okay, so if you want to switch between the branches, can use checkout command. And next one, merge, I said. So what merge will do? We'll get the code from one branch and it will add it to another branch. It's clear for you? Fine. So up to now we discussed like what is Git repository and what are different layers of Git. Okay, and how data will flow in Git. We discussed this, right? And next we are seeing what are different Git terminology we are seeing here. Okay, we discuss what is this master. Master is a primary branch, branches, another line of development, tags, some named snapshots, right? Then how can we do the things practically? So here we have to create one account in GitHub. Okay, we have to create one account in GitHub. Okay, for next class you can also try this one. You can just search for GitHub. Search for what? GitHub.com. You can just go with this and create your own account in GitHub. Okay, you can create your own account in GitHub. Okay, it's free. You can also try this one. Just provide your mail ID, so it will create one new account for you. If you have an account, you can just sign in. You can sign in. Okay. So it is my account, some Sathya Devops. Okay. Okay, it is my account. So once account is created, you have to create some repository. Okay, how to create repository? Can you see this option here? Start project. Okay, select this option. Um, Here I am creating some new project. Okay, so I'll specify some repository name. My repository name is some dev 6am. Okay, it is my repository. So it is under account Sathya Devops. And here we have some options here. What type of repository you want to create? Either public or private repository. What difference here? If it is public repository, so anyone can access this code. Okay. So if I add my code, then anyone can access that code from this public repository. Okay. And if you go for private, only authorized users can access. So who is having some proper credentials, so they can only access this code from private repository. And one thing it is, if it is either public or private repository, then who can commit that code? Who can push the code? Only owner can push it. Okay. So if I'm an owner, I can push my code. I can push the changes, right? But others cannot add their code for this repository. It could be either public or private. Okay. It's clear for you. So if it is public repository, so anyone can see, anyone can access the code from repository. So if you want to create private repository, you can create it, but it is chargeable. Okay. So you have to submit your credit card, debit card details here. So that is chargeable. And go for public repository is free. Okay. So you can create your own repository here. In every repository, we have to initialize a file called readme.md. What's the file? It is readme.md. Okay. I'll just show this process for you. Fine. What is readme.md? It's a file which contains some metadata. Metadata. It contains some information about this repository. Okay. So I will call this file as a readme.md. So it contains what? Some metadata. So let me select this one and finally create repository. Okay. So a new public repository is created. The name some dev 6am new. So which contains what? A file readme.md. Okay. What is metadata? I said information about the repository. So like who created the repository for which project and what type of code it contains. You can write some metadata, right? So for next class, you can also try this, like how to create this Git repository. So create your own account and you can try this process. It's clear for you. Fine. In next class, we'll see like how to install Git on a machine. We can see these things in next class. So any queries up to now? Any questions? Okay. It's clear. We have discussed some details about this Git repository. Okay. And how to work with the Git, we'll see on tomorrow. So any questions up to now? Yeah, Git must be some private. Actually, we have to go for private repository for organizations. Okay. GitLab, yeah, GitLab is just like your GitHub. I said right. In GitHub, I'm creating my own account. I'm maintaining, but this GitHub is one public repository, so anyone can access this code, right? No, I want to maintain my own repository. Okay, at my local system, I'll go for GitLab. Okay, I will discuss the GitLab later. I'll tell you. Okay. It is cloud or any local system. Yeah, actually, GitHub is definitely cloud, so we cannot access through local systems. Okay. But GitLab, we can maintain our own on-premise systems. Okay. Okay, okay, right. Thank you. Okay, fine. We can see how to work on Git. We'll see on tomorrow. Okay. Uh, you can practice all those things. Okay. So if anyone has interest, you can also attend to other regular classes. Okay. From today, we're going to start at 8:30. One more new batch. So anyone have interest to attend these classes, so you can attend that to that batch. Okay. So at 8:30 at evening 7:30 p.m. So we have these two batches. Okay. So anyone has interest to attend some regular classes, so you can attend to this batches from today. Okay. For this batch, I'll send my documents. I'll send some sessions, all these things. I'll just give it to them. Okay. It is a regular batch. Okay. If anyone has interest to attend to regular classes, yes, you can attend. Okay. From today at morning 8:30 a.m. and evening 7:30 p.m. Okay. Right. Okay. Fine. Right. Thank you. We'll see you on tomorrow for the other concepts. Right.